Hey, PerfBytes listeners, before you get started with today's episode, please pay attention to this message from our sponsor, SmartBear.
Whether you want to load test your APIs or your browser-based applications, you need to be able to easily scale up volume and identify problem areas. SmartBear has you covered. Load UI is the rock star of API load testing. Using an intuitive, versatile design, Load UI gives you the power to scale up and out, letting you dial up high volume and real-world load from any number of local and remote computers, all within a single test environment. With Load UI, it's easy to create and configure tests incorporating all of your OS, application, and database statistics agentlessly. It's fully interactive too, so you can easily modify your test and fix errors on the fly. Load Complete is an astonishingly easy-to-use load testing tool for HTML, AJAX, and rich internet applications. Create and run automated load tests in minutes using a browser to naturally record your interactions with your website or app. You can scale up the number of virtual users, pull in data from Excel and other sources, monitor server resources during test execution, and even distribute your tests geographically. Reports and charts make it a breeze to explore aspects of how your site or app performs under pressure and ultimately pinpoint performance issues proactively. Load UI and Load Complete by SmartBear. Ensure outstanding performance across your entire web stack.
It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day.
Don't bogart the PerfBytes.
Waffles.
Microwave ready.
Blobbity blob. Blobbity blob.
Add nutritional value to your brain.
It's time for PerfBytes with your hosts Mark Tomlinson, James Pulley, and Howard Chorney.
PerfBytes.
Whatever! It's time for PerfBytes. Welcome, PerfByters, to another episode of PerfBytes, or, as Ash Winter says on Twitter, welcome to the perfect balance of useful insight and outright bizarre giddiness. Gotta like that, James.
I know that is nice, isn't it?
It is. It's a really nice sentiment. Thank you, Ash.
I think it's a lot to live up to, though.
I think it's the equivalent of what somebody might put on iTunes as a review. We could okay. I mean, Ash, you could do Twitter's great, but throw it on the review there, so people with money will see it, and then they'll like us more. But of course,
I still have to go look up giddiness, but it sounds good.
We're giddy. And it was in particular, it was about the What's Up with HTTP 2, the Scott Moore episode, which I think at the very end included Ride 'em Jackalope. So,
yeah, that is true.
Howard and the Way Out West would be the Howard, who of course is just working his butt off for some customer tonight, and unfortunately not unable to join us tonight. So he may send in some recording. We may insert that along the way, but it's back to the good old days. James, just you and me.
Well, Mark, I got to tell you, this topic just speaks to me. And I'm sure it speaks to you because it deals with a former employer of both of us.
I know. We're going back to Microsoft land and talking about .NET performance. It's that Microsoft thingy they wrote back in 2002 or something. Runs all the appy things.
Yep.
Yeah.
So I think we need to start off by giving people kind of a little .NET primer.
Sure.
For those people who aren't really familiar with what this .NET thingy is. Well, it starts with this thing called the Common Language Runtime, which you've got a couple foundation layers here, which involves some data types, some memory handling, garbage collection, things of that nature. And then on top of this, you have the ability to use multiple different languages where, because of this strong data typing, they can pass information from functions built in language A to primary code in language B or vice versa. It's kind of cool in concept.
Yeah. So .NET hosts an application. It's a framework just like the JVM or the Java Runtime Engine, or the JDK would be the complete development kit. But the JVM, is the Java Virtual Machine, and the CLR is sort of like an application virtual machine, but it has some of the similar components, right? Apparently, back in the day, like Intel and HP and these folks got together and came up with what's known as the CLI, the Common Language Infrastructure. And the Microsoft's Common Language Runtime is the runtime that supports this standard for running applications on the base framework. Now, the base framework, much like the Java Runtime Engine, you don't need the whole development kit. You just need something to run your app. This CLR kind of gives you your basic stuff about multi-threading, system calls, obviously, and memory management, garbage collection. It's a multi-generational garbage collector. And then exception handling, logging, kind of all the basics of a framework that you need. And James, you mentioned on top of that, there's a very, very large set of classes or pre-built classes that come with it. And that's called the Framework Class Library. Now, what kinds of things will we find in there?
Well, you might consider anything related to file, network, common services such as database, things of that nature, that you're going to handle across different language interfaces commonly, and you're going to handle them consistently as well. So
things even like rolling an HTTP stack. You have an HTTP client that's part of that framework, and that's a standard .NET HTTP client. Or things, you can build GUIs, right? So you can have a .NET app written, a Windows form, or an actual standalone application. You can have command line applications written that run in .NET. PowerShell is a good example. I think PowerShell itself is actually written on top of the CLR. So you have a lot of things that are sort of use this runtime. And if we go way back, James, there were other runtimes in Microsoft's history, like the C++ had a common runtime as well that they had to distribute.
That is true. In fact, if you look back at almost every version of Visual C or C++, there was a set of runtime libraries that you shipped with your product. Now, something that's new and interesting with .NET is you have the capability of installing multiple versions of an application to multiple different directories. Mm-hmm. And from a library perspective, instead of looking at this common system library for, say, Visual C++ 7.0, it would use the libraries which are local to that installation directory. So you have the capability of having version A, version B, version C, version D on the same system. Mm-hmm. Or having different versions of different libraries on the system and not having them conflict with one another, which is kind of cool in concept. Most of the time it doesn't work out that way. If you're installing one application, you're not going to install multiple versions. Right. But for .NET commercial applications where they ship different versions of a standard library, not having to worry about a conflicting library version that's lower or higher in version number that's installed is really nice because they just install it and they don't have to worry about it because it's going to use their version that they ship. That's right.
And I think if anyone remembers, and I'm certain our good friend Satan would remember, DLL hell. Remember that phrase where you had to have your versions of your libraries and the conflicting libraries?
Isn't that in Dante's The Inferno?
It is Dante's Inferno, I think. There was one.
It's like the 12th level of hell or something like that?
I think it was in between the 3rd and 4th levels of hell. Dante's, he opened his laptop running Windows XP, SP2 without .NET, running an old Windows 3.1 app. And it just crashed through that little error up, and then freezes the whole machine. So this .NET CLR thing was the way out of around 2002. I guess it was being written in 2001 or a little bit before.
They did a big road show right around 2000, if I remember correctly, mm-hmm. And it was like a year or two later that it actually hit the market. Some engineering previews before that.
Yeah, Visual Studio.net, the first big rebuild of Visual Studio.net came out, and then of course Visual Studio is all the way up to now Visual Studio 2013. So they're very closely tied. If you're a .NET shop, obviously you stick with what rev of Visual Studio, and the next version of the .NET framework comes with it. So the current version is actually 4.51. It's been out for quite a while. Believe it or not, James, there's actually a dot release coming out 4.52 targeted for May, just a few weeks from now.
Makes you wonder why they don't brand that with a year stamp on it, like 2015.1. That's a January release.
Yeah, they used to do that back in the C++ runtime library. Yeah. You see those kind of embedded in those old 1997.3. No, I'm kidding. But yeah, so there's a lot of things, a lot of innovation that went in. I remember testing the first versions of the .NET Framework 1.0 and 1.1. JIT compiling was very, very slow. to start up. The caching was not done as a memory management very well. Garbage collection was just beastie. And we'll get into some of that in a little bit, but mostly people should know that the .NET framework itself is open source, whether you believe it or not. You can
now, Mark,
find it out there in the open source world.
That's just recently that's occurred.
Yeah.
You know, we all, or some of us may remember what's called the Mono project.
Yeah.
Which was an attempt to kind of clone the .clr runtime on Linux. And it was slow, it was kind of cumbersome and stuff like that. Microsoft and their new openness is now going to be building Core CLR, as how they term it, for both Mac and Linux. So maybe that's seeding a little bit of market reality, saying, hey, there's a lot of servers out there that are not running Windows, and we'd like to have our software on it.
Yeah.
You know, port Core CLR over, and then you have this standard services layer available that someone can deploy on a non-Microsoft architecture and still have it run.
Yeah, but still the flexibility per the intent of this common language infrastructure. You could write a C# app and run it on Linux. And the idea that it's just like Java, you can write a Java code and it runs on whatever platform, and that agnostic kind of capability is very nice.
I'm still waiting for that .NET refrigerator release for my Maytag, because I think my Maytag supports Java.
Well, isn't that running the embedded .NET client?
No, I think it's Java. I think it's embedded Linux.
Embedded Linux and mini version. Yeah. A couple other things that might be interesting for folks to know. I mean, one, you've got an adoption within Microsoft that actually took, I believe it was a variant of the .NET framework and turned it into the SQL Server runtime. So the SQL CLR, as it might be referred to. Back around 2006 to 2008, I think Katmai was a major step forward with the SQL CLR. So there is this idea of a common language runtime even for workloads like SQL Server. And then you'll see it predominantly embedded underneath any of the IIS or what is now ASP.NET. So ASP.NET websites, which are pervasive all over a Microsoft shop, running ASP.NET or a W3WP web app running on top of ASP.NET, that's all built on top of a .NET server engine. So it's one good way to think about it is that there's a server version sort of the .NET CLR, or as a way to configure the CLR to run on a server like SQL or running underneath ASP.NET. Or, James, there's also sort of the client or workstation version of the CLR. So there's different variants in the client as well.
And Mark, that really allows us to talk about what are the different client variants here. I mean, you can have a full-blown thick client, traditional two-tier or multi-tier with a lot of intelligence built in. You can have a little bit skinnier client, what they call the WinForms. Web Forms, which is another skinnier variant. And then you've got just a straight-up a web-style ASP or ASP.NET, which we'll get into a little bit later, and because I can't really talk about that right now, or we're gonna have an issue.
James has got a PerfRant coming up about ASP.NET. So you can build an application again with all of the CLR capabilities that runs on a Windows client. That could be a Windows laptop device, a PC. Think of it in a business context. You may have
hold on, Mark. Technically, it can run on Windows Phone, but I'll just say technically it can run on Windows Phone.
Yeah, there is a .NET portable kind of CLR that you can do as well in the mobile world. I think there's still a lot of work being done as we look at .NET running in Windows 8.1. I have a couple machines running 8.1 right now. So a traditional type of desktop that has the horsepower, I think they're still doing some things to minimize the overhead within sort of the client or mobile versions of .NET as well. But for the sake of our argument today, for the sake of our show today, let's just think about it in terms of ASP.NET and client side. Actually, since we do mostly load testing of concurrent systems back, we'll talk a lot today about ASP.NET and running .NET on the server and building large web applications that end up on the news of the damned all the time. Right, James?
Exactly. So Mark, what I would like to propose is that, well, one, we're going to go to a break here in just a moment. When we come back from the break, let's take a look at those items that we've talked about so much over the last 2 years, and let's build up .NET from kind of those foundation elements that our audience may already be familiar with.
So let's take a break then, like you mentioned.
Lightsquare.com is a proud sponsor of PerfBytes. Lightsquare is a unique offering for performance tuning as a service for web architectures. Lightsquare delivers tuning recommendations in under 72 hours without the typical investment in tools, license fees, or consultants, where we do the work up front. With Lightsquare, you only pay based upon the level of improvement. Find out more about Lightsquare's unique pricing model at litesquare.com/pricing.
Yes, exactly. All right. So if we go into kind of the first thing that you might encounter, let's say you're asked to jump in and start load testing a website running on .NET, or you're in a Microsoft shop. One of the first things you want to figure out how to do is how to monitor the system, because generating load on a website that's running ASP.NET, well, there's a few gotchas in there that we'll talk about with the Viewstate and some of the recording best practices, but the first thing you should understand is how to get your fingers and hands inside what's running on the server, and that's performance monitoring of a .NET app. And that could
and Mark, it's really no different than any other application in this sense. We have our traditional finite resource model of CPU, disk, memory, and
network.
Exactly.
That's right.
So there are corresponding metrics that are tracked for the .NET CLR and for the base operating system that go along with this finite resource model.
Yeah.
And so let's take a look at what those components are specific to .NET that you're going to want to look at. Mark?
Actually, before we go into .NET, let's take a look at what happens inside a tool called perfmon. And in perfmon, which is the monitoring and sort of measurement tool in a Windows operating system, it's almost every version of Windows. You should have permission to run perfmon, unless your system administrator group policy people turned it off, which is silly. You need to ask them to enable your rights to run perfmon, but mostly it's there. And if you go into Task Manager in a modern Windows application, you'll click over to the Performance tab, and there's another button that says Resource Monitor, and that'll take you into perfmon.
And I think if you go to the command prompt, just type in perfmon, it will take you there automatically.
It might take you there. But there's some specific counters for the CPU disk memory network that we want to bring up. The first is just the system processor. So looking at the system processor, system time, total processor usage, and particularly we like to look at the processor queue length. And this looks at the number of threads in the operating system owned by the system and takes the total number of threads queued and divides that number by the number of the CPUs in the system. So basically the idea, if the answer is less than 10, the system's most likely running well, because a lot of systems are quad-core. Server systems are probably dual quad-core at 8 or 10. Basically, each processor should show 1 or 2 queue length currently. So if the system is really backing up, we're talking at the operating system level, then it'll be much greater than 8 or 10 or 16, 2 per core, 2 per processor. So that's system processor queue length is probably the biggest one to see the health of the CPU. And obviously, if you see that the processor queue length is backing up, most likely the CPU is already running at 100% CPU, right, James?
That is true,
yeah.
or close to it.
Or close to it.
And going along with that, this concept of an overflow, you've got this queue length. If the queue is getting too long and you're backing up, you've got memory. What happens if your memory is too full or you don't have enough physical memory to accommodate what's in RAM? Well, you're going to start doing this thing called swapping, which is bad, which is you're going to take segments of code which are marked as swappable, and you're going to put them out to the disk. You do have a way in perfmon to track the behavior associated with that, which are misses in memory, and also having to retrieve memory pages per second from missed hits. So you can track how much swap is going on. Now, here's an interesting tidbit on performance testing tools, and for the life of me, I've never been able to figure out why this is the case.
Yeah.
All the commercial testing tools, their code that runs on Windows is marked as swappable. So if you put too many virtual users in memory, then can be sustained, you start putting virtual users swapped out to disk, which is why you see the disk light and the CPU light going mad on an overloaded load generator that doesn't have enough memory, because it's constantly pulling users back and forth off of disk. And if you add logging to that, all of a sudden you are basically taking the read-write head and warping it in space-time.
That's correct, and you may end up like Michael McConaughey, stuck in a black hole somewhere trying to manipulate gravity. But exactly. So the counter I look for that, and these are some recommended ones that I've used or found, and one is memory, the memory object for pages input per second. And basically, James, it's okay to write a page out to memory as long as you're just throwing it away and the app can move forward and not worry about it. The real problem in swapping is when I have to pull that page of memory back from the swap file off of disk. So this
completely agreeable. Yeah, I got you there.
Yeah, with memory pages input per second, that's how much time or the rate at which you're starting to read pages of memory back from disk into memory to use them, and that's usually because you've got misses or page faults happening. So that's CPU and memory. The next one we'll look at is disk, and of course, there's logical disks and all sorts of stuff that people talk about in PerfMon. I like to stick with physical disk. Physical disk is a knowable spindle infrastructure. I can trace it to a drive, no matter what drive format that is, what the channel is, whether it's fiber channel or SATA or SAS or whatever it is. So physical disk, just looking again at a queue length, the current disk queue length for a given drive letter. So the nice thing in Windows is most drives have letters. Almost all of them do. You can have mount points and things like that, obviously using other disk drivers or storage drivers. But for the most part, you have a D drive, a Z drive, a Y drive or something. And this will probably show you whether you're starting to queue up I/O requests, trying to either read or write, and looking for that.
And Mark, what I tend to look for here is I tend to look for a static condition.
Yeah.
I don't want to see it growing or shrinking too much. I just want consistent performance. If I see that my queue length is increasing, I know that I have some sort of contention on the read-write head for that drive letter. It may be I need more spindles in the array up to a maximum of 9, which would be 8 plus 1 parity bit. Or I just need to be writing data someplace else, that I just have too much data to go through that one interface.
Yeah, and it depends on where you place your swap file too. Most people have a swap file on the C drive, but you could have a dedicated drive if you're going to be doing a lot, have that page file put on other things. So you can look at the storage I/O that's happening because of the former counter we said for swapping.
And some things that I like to do in a Windows environment, I actually like to dedicate my swap to maybe a section of physical memory if I've got enough for it.
Sure.
I like to dedicate my temporary files to a fairly fast drive dedicated just to that. And if I've got a database server and a web server involved, I want them on separate disk subsystems.
Oh, sure. Yeah, logging on a separate disk system.
Absolutely.
Or if you're in the SQL world, you can have very elaborate storage partitions and distribution across.
Oh yeah, I like my indexes on very fast static RAM drives, and my data on nice slower big drives.
Logging separate, tempdb separate. You can make a really, really screaming SQL Server system by just getting after your storage. Now, the last resource, one of the slowest, and potentially one of the more unreliable ones out in the real world, is a network. So network interface, you want to look at the network interface in PerfMon, particularly, again, an output queue length, which is you want to send requests from your server outbound, but if your local process is backing up on itself, or those requests are taking so long that they can't complete in a fair amount of time, you can look at the output queue length of the network. It's a number of packets in the queue waiting to be sent. And again, we're looking for something that's under a steady state, remains constant. But one of the major reasons that the network will kind of screw up for you is when it starts throwing errors. If you have an unhealthy physical infrastructure for the network, or even the remote system is unreliable. So also look at packet received errors, because James, if you receive an error, you might have to resend.
And there's a corresponding item that goes along with that, Mark, which is retransmits. So if you see a high amount of errors and retransmits along with the queue length that's backing up or growing, that gives you an indication that you've got some sort of network condition that you need to address.
Yeah. So that gives you the basics of Windows if you've never been on a Windows box. And you'll want to keep an eye on these core counters, CPU, disk, memory, network, while you get into monitoring the .NET worker processes. And so the real way to think about monitoring .NET is that there's sort of a set of CLR counters, and you can think of those as the core counters for the infrastructure of the .NET framework. So things like the bytes in memory and the core threading, exceptions, all that kind of stuff. And then there's usually a worker process or the app layer. So the .NET app counters, which tell you all about the app that's running on top of the CLR. So think of it in two different ways. Like in ASP.NET, it used to be the ASP.NET worker process. Now you have the W3WP worker process. But usually it's something WP.exe or something like that. So that will be the app, but you want to look at both what one app or app pool is doing. And if you remember from the SharePoint episode with Andy, James, we were talking about SharePoint having app pools. And so we'll first start talking about monitoring the .NET CLR, the core system of the CLR. And the biggest areas that I find are the most beneficial areas to start monitoring when you start bringing up the load on the system is to keep an eye on memory, because memory and garbage collection have been historically the most troublesome areas for performance in the .NET world.
Okay. So Mark, I want to stop you right there.
Okay.
So you said memory and garbage collection are one of the most troublesome areas in the .NET world. Where else have we had that issue?
Java?
It's Java. So if you can look at the .CLR as Microsoft's answer to Java, write once, run everywhere type model, that's really what it is. And so there's a lot of parallelism in architecture and concepts and also in challenges as you look at Java and .NET facing some of the same challenges because they have some of the same design goals that has driven their development.
Yep. And so just like Java, the number one thing I see is that applications just run out of heap. They run out of heap. They can go into a swap condition, or more aptly, they'll just throw an error out of heap, out of memory error. And even though there's exceptions being handled, usually badly built applications will do that. So you're going to want to be aware of the physical memory that's available. If you're in a virtual machine, you want to know how much is allocated to your, on the hypervisor, what's physically available, how much is allocated to your particular Windows VM, and then you'll want to look at how much actual memory am I allowing my worker process to go to, which is why almost everyone is in the server world is on 64-bit Windows. So you should have a large addressable space to grow an application to become very large. So the biggest thing you want to look at is the number of bytes in what's called all heaps. So you're looking at all generations, even the G0, G1, G2, large object, the free space that's allocated, the buffer you have. And usually when you're monitoring those bytes in all heaps, if you're looking at the allocation across that, you'll see this sort of sawtooth pattern where it kind of creeps up and then boom, you'll see the memory go back down and the free space will free up. And that's the deferred garbage collection where things are getting marked. And you should see a very healthy rising up and then drop down and rising up and drop down and rising up, drop down is usually a fairly healthy, steady state profile. Not blowing out the heap, but you see this sort of allocation and then cleanup and allocation and cleanup on a periodic basis.
So if there's one axiom, is that bad developers are platform agnostic. And there's a truism to both Java and .NET is that you need to mark the memory as no longer being used in order for the garbage collector to work effectively. So just like .NET, if you see the sawtooth pattern that's gradually rising over time, that it's not coming back to this common baseline, you know you have a leak in some sort of .NET object inside of the CLR. And we need to take a look potentially at how to diagnose what's going on there and the type of tools that you would use. So Mark, do you have any thoughts on that?
Well, there is a CLR profiler, but even in the .NET, just in perfmon, you can look at allocated bytes per second. So you can see if the allocated bytes per second, if you're basically allocating more than the frequency of cleaning up, you've got an issue. So you're going to grow. At the same time, James, when we tell developers, you guys need to get your memory collection act together, usually they'll start throwing a dispose function all over the place. Like they'll put it in a framework library that gets called 100,000 times a minute. And so you can look at another counter in perfmon in the garbage collection that's called the number of induced GCs, which are explicitly coded garbage collection disposals, where you can have people doing over disposing will actually cause tremendous overhead, and you might be better off actually easing off on the intentional explicit GC and just let the garbage collection actually do its job.
And let's talk about why that explicit garbage collection is expensive. We got to go back to some core operating system concepts here. Ring 0, which is system events that have to be handled immediately, versus layer 3, which is application events, which can be put on hold while we handle a system event. So this is kind of an Intel processor architecture, Microsoft software architecture model. And in layer 0, which is garbage collection event, everything else has to be put on hold to wait. So you have a finite number of CPU cycles. If we're using a lot of them for garbage collection, we have to put the application on hold, and application performance will suffer in that case.
Yeah, think about it from a promotional standpoint. Like if you have generation 0, which is the very first, it's sometimes called Eden in the Java space, right? It's the first place of memory, usually the processor cache, where an object gets created. You create a string object for your first name, last name, address, fine. So you create a string object, and then if you get really, really frequent in your intentional explicit disposal, you'll try to clean that up even before it gets promoted to generation 1. And generation 1 might still be in L2 cache. It might be in L3 or L4 cache on the physical machine, or if you're in a VM, it's still on main memory, but it's still in the first few blocks of frequently cached stuff. So if you over-dispose in generation 0, generation 1, you're right, James. Those are the most urgent, immediate type of short-lived kinds of things. Versus don't over-dispose and get your number of induced GCs down, and just let the background garbage collection do its job in generation 2 or large object or older objects that get promoted. And then they're not as sensitive. Those objects don't get the priority on the system that other ones do.
And Mark, I believe we can take advantage of parallel garbage collection in that case for a minimal type of hit.
We can, and that's called, we'll talk about that in the tuning section and in the next section about background garbage collection. But there's another thing, James, that we can actually advise developers to do to reduce priority instruction processing in the system layer of the kernel and system time. And you know what that is?
Tell me, Mark.
Exceptions, exceptions, exceptions. The only thing about exceptions is they are not the exception.
I don't know what you're talking about here, Mark. I need to go look something up.
So exception abuse is like try-catch abuse. If you know something is 99% of the time going to throw an exception and you're just coding it with a catch routine versus altering the structure of your code so that you're doing the positive case, the non-exception flow of your code, that's something every developer should learn how to do, because guess what happens when you abuse an exception?
Well, exception code is typically not optimized. You know, it's
really heavy because you have all the logging turned on,
and you're usually doing all sorts of string processing, which is expensive to the OS as well.
Yep.
So it's just heavy. It's like bike riding up a mountain wearing weights on your legs,
or carrying too much water.
Sure. Well, either way.
Sure. Yeah. Exactly. Or just me trying to bicycle up a hill, because I'm a heavy guy going on a bicycle. No, James. Actually, the system exceptions, for every little exception that a developer might see at the upper level of the framework or above in the CLR or in their app, underneath that exception, there could be a whole chain of system-level exceptions. And guess what?
They get inherited, and they have to be processed.
And they get priority on the kernel.
Yeah.
They run in system time, and they compete with kernel mode drivers that are trying to do the work. So if you have exception abuse, I mean, honestly, you should see a big fat goose egg in exceptions thrown per second. That's healthy code. If you don't, you're going to see this jerky, spiky activity in the CPU, and your system times and the priority time in the kernel is going to be crazy. So definitely monitor exceptions thrown per second.
Mark, there is something that's a complementary statistic as a check value that you can look at. There's this concept of both system and application in the CPU, how much of it is divided out dealing with OS issues versus application issues. And all of these items inside of .NET get broadcast down to their primitives in either the operating system side or the application side when they're running.
Right.
So if you see that your proportion of application CPU to system CPU is not healthy, that is, you want that system CPU to be fairly small. I like to see it less than 20 to 25% on average.
Oh, I'd say even less than that if you can afford it.
Oh, sure. Minimal if you can get it. But if you see it growing and taking up a substantial amount, that should be a good clue, and that's not even a .NET metric.
No, it's not. Actually, you can get there through the task manager in Windows. Yep. You'll see on the processor bar, you'll see green and little red bars. And so you see the little red bars in there. You're like, oh, that's system time. Let's say you've got a storage driver or you've got a network driver that's running in kernel mode. That kernel, that's the Windows operating system. That's the OS kernel that has to prioritize getting those low-level calls done. So if your abuse of exceptions as a developer starts to hog that system time, you'll actually interfere with the overall throughput of the system in that way. So we talked a little bit about garbage collection, but there's also a general thing to look at, which is percent time in GC. So it really doesn't matter where there's time spent within all the different garbage collection efforts. It could be collection, it could be running the different threads, it could be promotions, it could be finalizing things, putting stuff into large object, whatever. If there's another counter in PerfMon called percent time in GC, and, the old metric I used was about 20%. If you are over 20%, we've probably got to take a look at something that's not healthy.
Yeah, and that kind of corresponds with my rule of thumb of 20% in system versus app.
Yeah, I think that's about the same as well. The last thing I like to monitor in the .NET CLR, we haven't talked about ASP.NET yet, in the .NET CLR is looking at threads because just a little primer on configuration, usually you have some defaults within .NET in terms of the same thing with the JVM and different Apache has the same thing. There's sort of min and max threads. When you fire up the worker process, it's going to create an app pool, and that app pool will have n number of threads assigned to it. And let's say each one of those threads takes up a meg, and you've got 1,000 threads. So you're going to have about a gig worth of memory. But let's say you've got 16 gig on the machine, and you can only go up to like 1,000 threads. Well, you may bump that number way, way up so that the max number of threads is actually operating healthy. So there's some things you can do around health for threads is to look at both the contention rate. So if you have a contention rate per second and you see some queuing, we'll talk about activity requests in the ASP.NET, but there's a contention rate per second and also errors per second from the threads. So if you try to create a new thread and it can't get a lock and actually spin itself up, then you're probably either hitting an artificial ceiling on the max number of threads or you've actually run out of memory space to open it. The other thing is just generally monitoring the number of threads. So you can look at logical and physical threads within the CLR. And know what those max threads are, because the idea is you want to create a nice set of threads that aren't competing or not in contention, not throwing errors, and it's like a multi-lane freeway. So if you have 10,000 users on a given machine, you can have 10,000 connections with 10,000 threads, and it just goes really fast. That's a huge number, by the way. But maybe it's more like 100, but you have 100 threads that takes up 8 gig of RAM. So that's kind of monitoring threads is the other thing for the health in the CLR that I like.
And thread leakage is a problem. where you allocate a new thread, you're not deallocating at any given point. It holds memory, it keeps running, and you may have heard the rule of thumb of, oh, we've got to reboot our Windows servers every n number of days or hours or whatever. Well, that typically goes along with these development practices where people are not recollecting the resources that they're allocating. So if you see a number of threads that are growing, either in system or application side of the house, and they're not coming back to a steady state condition, rest assured you're going to be in that practice of, oh, we have to reboot our server every so many days. And that's not a good place to be because, as they say, bad developers will consume whatever resource pool is available.
Yeah. This is a good time to talk about ASP.NET then, looking in the app, particular app pool or app layer of .NET and looking at that activity, because James, think about a 20-minute default session timeout, and you have a thread that was set open, and the developer didn't write it in a way that would clean up after itself. You could have something, it has it's holding on to a few objects, didn't dispose them, didn't get cleaned up, and it's just waiting. Let's say it only took 2 minutes for the user on the site, but it's holding that thread out for another 18 minutes doing nothing. It's just sitting there, and then they're waiting for the session to come around and expire for it to actually clean up. So attaching things to the session object, that's what can cause those sort of orphan threads, and that hogs up memory, and that hogs up resources, and then it'll bring the system down.
Yeah, I had to have a heart-to-heart with a young developer on this subject very recently, attaching stuff to session, and then talking with the server administrator about managing session timeout, where they were facing competing challenges, one from marketing, who really doesn't understand the cost associated with something, saying, oh, no, you can't time them out. You got to allow them to be on there for at least 30 minutes. They're going to come back. They're going to buy. They're going to buy. They're going to buy. They're going to buy. When in reality, anyone whose session goes longer than 10 minutes in total, if they don't buy something, they're probably not going to buy.
Yeah. So just hang up the phone on them and they'll come back.
And the page-to-page transition, the maximum was about 5 minutes. So if you get beyond that 5-minute maximum, you're right. Just hang up the session, clear everything up, because when you get a large unexpected load, boom, you're going to fall over. You're going to run out of resources.
And if it really doesn't cost much to spin up a new session when they come back, and let's say you have saved their cart in some way, in an efficient way, I mean, it's cheaper to fold the session and end it in 5 minutes, and then just spin up a new session when they come back. For that
0.5% that go beyond the 5 minutes, it's less expensive to retrieve their session information from some sort of storage than it is to maintain it for the other 99 point something percent.
Yeah, and you're punishing everyone else who's trying to actively buy something because you're waiting around for one guy who's undecided, and that's not how the world works. But yeah, don't abuse session is a great thing. It's there mechanically to support the operation of the functions of the app. It's not there in a logical sense to support a customer. So build a customer object and do things in caching of the customer object and store their data separate from a session. A session is mechanical. A customer object or a cart object, that should be explicitly put together. So let's talk about activity. When you're ramping up load in .NET, particularly ASP.NET, obviously, you're pushing requests through the system. So the number one thing I would look for is just requests per second. So you can see the throughput. And if your load generator is ramping up and you're ramping up virtual users, you should see a correlating requests per second increase as well. They might not be one-to-one. So you may have a front-end activity that does one hit in, say, Load Runner or Cloud Test or whatever tool you have, that you may see 12 requests per second on the app server. It's not necessarily a one-to-one relationship. Don't be freaked out about that. But as load ramps up, requests per second should ramp up. And at some point, you keep an eye on requests queued in ASP.NET, as well as the request wait time. So even if you haven't queued up requests, if your request wait time is, say, 4 seconds to go to the database, get data, and come back, you can know on the front end, you should see some kind of correlating wait time. And at some point, when you ramp up the number of requests, it'll start to queue up requests because you've overloaded the database. There's blocking in the database. There's not enough memory to open another request, so it has to kind of wait for that request till it can get a thread in the thread app pool to fire it up. So request queued tells you, oh, we hit a bottleneck in the app server.
And Mark, this is a good time to talk about process. I know there are a lot of people who are listening to us who wonder, what's the best way to start a test? Well, I like to start a test with a ramp up. So as we're dealing with these issues of queues and watching queues filling up, or we're looking at increased time going from one object to another, going to the database as an example. If we start at user 0 and we queue up, say, or we ramp up over a 20-minute window, we can actually watch that time increase as we hit a bottleneck. So we can get to a certain point, and then we hit what's called the hockey stick in the curve, and then that time goes up, and it starts going up exponentially at that point. But it gives us a cutover point, particularly in a .NET universe. It's pretty clear to see that we can then go back and say, okay, we have a problem at X, and let's look at what our finite resources are at X that are causing this issue.
Yeah. And, it's different than a spike test, James, but even a spike test, I'll do a little ramp up, steady state, and then boom, spike it. Because in reality, most systems are running even at low level all the time.
True.
So you're never going from cold to 100% in less than a second, unless and certain applications do that, certain systems, but usually they're not the standard website type apps that we see out there. It'll be very specialized kinds of things, and also microcode embedded systems that have to go from 0 cold to 100% in a microsecond. That's a totally different thing, not in ASP.NET. So the other thing, the first thing that usually happens when you throw brand new code at a .NET application is it's got to compile just in time. In fact, there's been some innovations that we'll talk about over what they call JIT, just in time compiling.
So Mark, once again, that sounds so awfully familiar. This concept of compiling code first time it runs.
Did you used to work at Sun or something? IBM has a JVM as well. Maybe it was IBM just north of you there in Raleigh.
Yeah.
JIT compile. It's been out there. It's actually been out there in a long time, but it's part of Java. Java has JIT compiling as well. And that's the first overhead you'll see if you ever start an app from cold. Even workstation client-side applications, the first time you start a Java app, just fire it up once and then close the app and open it again. It'll open up faster because usually everything's loaded and warmed up in memory. So it can load those libraries more frequently by the operating system. But even in the caching, once you compile, you have the interpreted language, so the common interpreted language.
Basically, it's the bytecode at that point.
Yeah, it's bytecode, and the idea is that the first time you hit an ASP.NET app or any kind of .NET app, it's got to compile it or make sure it's going to check first. Hey, have I already compiled this app? Do I already have it in the cache? So another thing to monitor is the compile time, particularly on those apps where it's a clean installation and clean startup. With ASP.NET, you don't, the first load test you run, you might do a little smoke test just to kind of warm it up and ramp up, as James said. That's a totally good practice. But then over time, as you bring new applications, if you're monitoring in production even, you want to look at that ASP.NET application for the cache API hits and the hit ratio. So if you see there's a lot of, you wrote a script that hits path A, and path A has 40 objects that get compiled, and that's all that code, those assemblies put together, and that's all bytecode sitting in there. And then in reality, there's 40 other paths that hit other pieces of code and other objects and other classes that get loaded in memory. Those cache hit ratio might be very different. So looking at the cache hit ratio might be that the scripts that you wrote were too perfect. Maybe they're too minimal. They're not diverse enough. So randomization within your scripts, parameterization, slightly different logic flows within the script, getting your coverage of the flows to match production
and Mark,
is a good thing to do.
Good time if you've got a public facing website you're probably going to have automated agents using your site in ways that you never expected. So taking a look at that cache hit ratio can show you if you have an unnatural user population that's hitting pages and hitting code that you would have never expected to be hit.
Yep. But definitely sort of looking at the activity in the request queued is a dead giveaway that something is backing up within ASP.NET. And then you would work backwards and say, all right, do I have enough threads? Do I have enough memory? Am I swapping? And then work your way back up to say, well, what do we need to tune within the ASP in the app config to make sure that can work? Now, don't forget also that there's lots of tools out here that allow you to dig in. You can get in with the .NET CLR profiler. You can profile the code. The older versions of this CLR profiler were so slow, James. They were awful. I never wanted to open them under load. The newer versions, because of some other changes that they made, is actually pretty efficient. Again, I wouldn't use it in production. I wouldn't use it under big load tests, but maybe one of the web servers that you're running, you could do some profiling. Usually, process-wise, if you're going to be doing a debugging or a diagnostic session, you're not running full load. You're just going to run a smaller, maybe 10% load and do some debugging or profiling. But there's other commercial products, HP Diagnostics, Dynatrace, New Relic has some great stuff, and Visual Studio as well. The latest one, if you're using Visual Studio, you can actually put in the ETW tracing. You can get all sorts of cool stuff.
And let's not forget, Visual Studio has the ability to create new performance counters that show up in PerfMon as well. Yeah. So if your developers are quite adept, they can take individual objects which might be problematic, and they can export statistics to PerfMon, which can be picked up directly out of PerfMon or through the simple network management protocol interface of Windows.
Yeah, and that instrumentation, in the old days, instrumentation was expensive, but not anymore. The PerfMon API is completely async within the kernel, and it won't drag your app down at all if you use the standard library.
Take advantage of it for those areas which are of a concern. Put out metrics so you can track it in operations to know your system is healthy or not.
Yeah, very, very good. So those are the things you're going to look at and think about as you're monitoring the first .NET application that you run. James, let's take a little break for some more public service announcements. I'm going to have another sip of wine here as well.
Okay.
You know them. You see them hit the end of an iteration and they just plain ran out of time for performance testing. You hear them convincing the VP of development to just fire all the testers. You see some other kids aren't testing at all. And you see the cool kids are now testing in production. It can be tough under all that peer pressure just because you want to be cool too. But being cool isn't as important as it seems. PerfBytes encourages you to keep your own commitment to quality steadfast and not give in to those trendy, cool hipsters who don't know how to test. Stand your ground against emergency promotions and too fast releases directly into production without any testing whatsoever. Know that PerfBytes supports you because friends don't let friends deploy without testing.
So Mark, we've come to a section in .NET that is a little problematic. And I've kind of referenced it earlier, which is this ASP.NET thing. And we're going to combine that with the topic of tuning for .NET. But boy, this ASP.NET, that's right up there, number one from a tuning perspective. And I feel something coming on here.
It's time for a PerfRant.
So, Mark, I got to tell you, right around, I'm guessing it was 2007, 2006, maybe 2005. I just hired a bunch of people. We had a bunch of work. We get into looking at these applications, and darn if they aren't .NET Viewstate applications. And even before we ran the first performance test, I was citing defects, because Microsoft, in their infinite wisdom, had decided that every possible thing that a developer might put on the screen was going to be in state. And we were going to pass that information in a base64 encoded object from server to client. And then the client would have to pick it up and hand it back to the server. And in this case, this was still in an era where there was still in a large amount of dial-up, and the state management variables were well over 1.5 megabytes in size. How do you think your average AOL-based browser is going to respond to that when someone is looking up their retirement account? Not very well, thank you very much. So, thankfully, over the last few years or decades or generations of Visual Studio, Microsoft, in their infinite wisdom, has trimmed back what's the default in .NET View State. But still, you could have developers who have these old practices, throw everything in state, because no one's telling them not to do that. And so when you record a ASP.NET application or .ASP application, very first thing you should look at the state management variables. And by God, if they're larger than graphics, if you're looking at 400, 500K for a state management variable that's being passed back and forth, cite a defect right then, right there. Don't even wait for the performance test. Because somebody's doing something as a default that's a bad performance practice.
Did you get that out? Did you get it all out? Just the tip of the iceberg, wasn't it?
It's not all out, but we only have a 1 hour show here.
The good news is in the early versions of .NET, you're absolutely right. ASP.NET, where the old ASP world was transitioning to .NET, there was the default set that every control on a web page of fields, tabs, you name it, the default was to enable view state. And so if you didn't know better as a junior developer, you would leave them all on. And I've seen view states like 2 meg, huge.
I saw one time that was over 16 megabytes because they had it like an embedded Microsoft Access database object.
Yeah, really complex.
And so they were passing the full database back and forth.
Yeah, really
every
crazy.
Single time.
Yeah. So now that's not quite as much. So they've cleaned up a bunch of stuff, but third-party controls and such. So this is a good thing when it comes to tuning .NET, particularly ASP.NET. Just even recording with your tool, with LoadRunner, a virtual user, you can look and see what that view state looks like. You see these huge encoded blobs, base64 encoded blobs of like, what the heck is that big thing? And it needs to be correlated in your script. Oh, you're right, James. I feel so bad. It's so painful.
Yeah, and it doesn't matter. LoadRunner, Silk Performer, Rational Performance Tester, Microsoft Visual Studio, JMeter. If you see it, take it to the developer and just say, look, I have this finite thing called network. And this big thing that you're pushing through network is not going to work well because we have to share this thing called network, you see, with other people that are using network.
Yep.
So you need to trim this down to as small as possible.
Yep.
And what you do is you go in and you look at the properties on each of these individual objects on the screen, and you don't include them in state.
Yeah, things that you don't need state on that could just be like a one-time import saved in the database, throw the object away in view state. So that's the first thing, especially if you're deploying this object across a WAN or deploying the site like News of the Damned. We've seen ASP.NET sites out there full bore with thousands of users hitting them.
And dynamic content on page 1.
Yeah, dynamic yeah. So outside of view state, as painful as that has been, things are getting better, James. Just hang in there a little while longer. People still make those mistakes. We get websites out as fast as we can get them out, and that's when we need to look for things. And it's a hidden thing behind the scenes in your browser. If you look at the source code, if you look at you'll see these things in there.
So here's what I do in a .NET environment outside of view state, because that's easy enough to catch. First thing I do is I grab the SQL profiler from Microsoft SQL Server, because if it's .NET environment, odds are probably 90% confidence it's going to have SQL Server someplace.
Yep.
And the SQL profiler is nice, it's graphical, it's really cool, it works really well, and it'll show you all the database problems, index traversals, non-index traversals, wait times, access to disk, things of that nature. It works really well.
And the DMVs are right there, show you missing indexes and all sorts of index tuning wizard stuff as well. It's actually pretty decent.
Now what it won't catch, this is the bizarre one, maybe it will catch it now, is if you have a Unicode encoded index and you have an ANSI encoded query.
Oh, yeah.
That's my weirdest performance issue ever found.
Yeah, weird. You're paying a transformation cost in the middle of the app.
Exactly, and if you post that query directly into the SQL profiler and run it, that's all Unicode, so it takes advantage of the Unicode index. So that
that's a gotcha.
It's very difficult to find.
That's
a lot of beer, a lot of food on that one.
Yeah. So when it comes to tuning .NET, this is a similar process I used in Java or most app servers. Is this whole idea that you're going to ramp up a slow amount of load until you reach what I would call 1x, whatever your baseline 1x load is, just normal, what usage profile, analyze the real world, whatever you need to do. And you're going to basically make sure that the application, a single server, a single instance of the ASP.NET app, has enough threads in the app pool to support that load without maxing out the number of threads, while simultaneously not consuming all of the memory. So let's say you start out with 20 threads and you can only ramp up halfway. Okay, you go to 40 threads and you ramp up 40 threads and you're right at the max of 40 threads. And actually, if you ramped up a little faster or you did a 2x load, there's no way you're getting to 2x. So the idea is that you want to give yourself a little bit of headroom, but let's say we went from 40 threads up to, say, 50 threads, and suddenly I'm out of memory. I'm out of heap. So that's where we kind of want to balance, because with more threads, you need more heap, more memory. So you want to do this balancing act that says, okay, and for a single instance of the ASP.NET app, it's ideally 40 threads, but we run out of memory going to 50 threads. So I would recommend that you do 2 instances of the app, maybe 2 separate servers, physical, maybe even enough virtual memory, double the resources, and bring each of them up to 40. Now you have plenty of headroom for growth. You could go from 1x to 2x test, but at least you know now that you've got adequate number of threads to get transactional processing completed, and you're not artificially bottlenecking in the app tier on a limitation of threads and or physical memory.
So Mark, I think it's important here because you do have this concept of the .NET CLR, which is really it's a virtual machine running in the operating system, just like Java.
Yep.
I like to take a reference physical piece of hardware and run it also on physical versus virtual, because most people these days are running inside of virtual machines.
That's true.
On some sort of hypervisor solution. But it's worthwhile to know the overhead of the physical machine versus going to the virtual machine.
Yep.
In this case, because there is a hit, and you're looking at kind of a double level of virtualization when you do this by putting it inside of a hypervisor. Which
may still end up being performant, but you don't assume it's going to be performant because of that evil old word, over provisioning.
Yes.
Yeah. So if somebody's trying to fit 2 VMs that take 8 gig of RAM each onto a single machine that has 12 gig of RAM, yeah, that's not going to work. Or if you need 4 processors and somebody else puts another VM on that machine, now you really only have 2 processors of usage that you could use at any time. Consolidation is not all it's cracked up to be. We've already ranted about that.
No. The chief financial officer says this is the way of the future.
Yes. I've met the VMware admin. They're not really thinking all that well about the real world for app workloads. And we do them a disservice by not having robust load testing plans, because they don't have real good stuff to learn from. And that's the big problem. So let's move. So thread pools and app pools, that's a great place to start. Minimize the view state. Make sure your thread pools are tuned to support the transactional throughput that you need without running out of memory. Add more nodes in the app servers, multiple physical machines or VMs with enough physical resources to run them. The last thing we'll look at, I want to get into, we talked a little bit about JIT, and I know in the latest version of .NET, they've actually moved away from the classic JIT code that they had just-in-time compiling, and they started this thing called native image compiling. And I think it's that it doesn't do a full compile if only one part of the bytecode changed. So you can actually do rapid deployment, and you don't have to recompile the entire assembly and get it put into cache. So I think that's sort of what I read about native image compiling. So if it can run the native image, it'll run that, and if it needs to compile something else, it only does it by exception. Most performance optimizations nowadays are about finding a way to do less work And so I think that's kind of what's there. But the tip here is if your company is stuck on a really old version of .NET, like prior to version 4, I'll say, or even 3.5, chances are you're still using the old JIT compile, and that means app startup is really slow or can be slow, and it takes up memory in a spike at the beginning. It chews up CPU right at the beginning of the load test. So think about moving to a new version of .NET and maybe talk to your developers about taking advantage of this native image compiling. The last two things we want to talk about here, James. One, tuning garbage collection. I mean, the same as our good friends from IBM and Sun in the Java world. We have a garbage collector.
And actually, I think we have more flexibility now, version 4 of .NET than we've had previously.
Yeah, in .NET 4, they changed for the server side. You have a collection frequency called background collection. So it used to be concurrent collection. The CMS in the Java world is concurrent mark sweep. So concurrent garbage collection. Now in .NET, it's called background collection. Now, for garbage collection, there are two different profiles. One profile is workstation garbage collection. The other is server-side garbage collection. So if you're running a Windows Forms app that's running on your PC, that's going to be one thread for GC, even if it's running in the background. So you only have one, because mostly you have like a quad-core processor or probably dual-core, a lot of people still. If you're in the server world, then it's looking at massively concurrent environments. So background processing is the default for server garbage collection, and you'll always have multiple threads. There's this interesting setting called a GC server element that if you enable it, you set it to true, you will get, for every application that's running, you'll get a thread plus multiply that by every core that's registered with that Windows operating system with the CLR. So it's sort of easy to think about one thread per process per processor. So if you have a W3 WP worker process running, W3 worker process running, and it's running on a quad core, you have one W3 worker process on a quad core, it'll get 4 background server GC threads.
So if you're looking at deployment in, say, Amazon, and you are allocating faster than you're deallocating, but you know you can reach a steady state if you deallocate fast enough, you might actually have to go with a larger instance model inside of Amazon.
Sure, you could end up to get more threads of background collection in .NET, run multiple instances of the worker process. And in the old days, we called that a web garden, or you'd have multiple worker process instances. The default is one, but and if you can work with one, that's great because it keeps it nice and clean. There's very little contention, but you might have to actually logically get more threads in another way. Now, two good things that you're going to want to keep in mind here. One is if you don't have any options and you can't collect fast enough, that's when you might go back to the developer and say, we maybe need to reduce the number of induced GCs, so don't dispose so much, because you're really asking the GC threads to be too busy because you can't keep up. The other thing would be that you just dispose less. So you actually have some objects hang around a little longer, or a reusable cache system. So you create an object, but it's used by multiple sessions. And so it borrows that way. Or leverage a database. I mean, it's right there for you. The other thing to keep in mind is that with a generational garbage collector, there's generation 0 and 1. Again, the Eden generation in the JVM, generation 0 in the CLR. 0 and 1 are always not concurrent. You have one thread on each core, it's on each processor, logical and physical processor, but logical processor and a VM. So those are always not concurrent because they go really fast and they're really small. Think about a blob object, James, like an image that you might get out of the database. Maybe you're doing a reporting application or a PDF or something, some blob data that's huge. Let's say it's 3 meg. You're never going to store that in the processor generation 0, generation 1. According to the garbage collection or the memory generations, you'll probably promote that right to the very large object heaps. It just gets put right into main memory. And that can be garbage collected in a concurrent way in the background garbage collection, whereas a little string, a little integer, here and there, those little itty bitty hash things, they're really, really small, and you create them and collect them as fast as can be, or you promote them on out. So that's a good way to make sense of GC. To tune GC, again, you want to make sure background collection is enabled for the server and that you actually give enough processors, physical processors or logical processors to the virtual OS to actually get that many threads of concurrent garbage collection running. And there's always the same anomalies you have in Java. There's stop the world situations. There's too much % time in GC. So there's all kinds of things you can do under load where you just can't move fast enough to collect.
And Mark, let's go back to that rule of thumb once again. 20%.
No greater than 20% time in GC. Tune it up that way. If you absolutely have to, you're going to have to throw more worker processes at it in order to get the background collections to keep up. So you can actually spawn more threads. In some ways, it might be better to run it on a cheaper 16-way box versus an expensive 8-way box, just so you could get the virtual number of threads spawned out to do that. Two other things about .NET that are kind of goofy over the years. There's a lot of debate around managed versus unmanaged code. And that's because there was a shift from natively compiled applications in like C and C++ versus a .NET language like C#, VB.NET, where managed code is a compiled intermediate language, right? So it's C#. C# compiles to the intermediate language and can be run on top of the CLR.
And it runs in the runtime versus unmanaged code, which runs in the native operating
It's
system.
actual machine. It compiles to machine code. And
Yeah. So you can use all sorts of additional optimizations on that you can't use in the .CLR because it is more generic or broad in nature.
When you put these two together, James, that's where they don't quite always get along because you have to, the .NET CLR has to spin up a container.
And you've got to be really, really consistent. You've got to be careful with your data types. You've got to make sure that they're compatible with the .CLR data types. You got to make sure that your memory is very self-contained and you're not tromping on potential memory that's going to be used or swapped on the CLR. So you're right. This whole concept of running managed and unmanaged code together, Microsoft doesn't like you to do that. They would rather you run all managed code. It's just simpler and easier.
But running them I think there's another move here for people. If you find there's a couple perfmon counters around interop calls per second. So you can see in the CLR if it's making a call out to unmanaged code and you're paying that interop overhead, you might be better off instantiating that unmanaged code as a remote web service, a microservice. So it can stay up and running and isolated, managed in its own space, and you just make a web service call to it.
Hold on, Mark. You're not going to suggest using DCOM?
Oh my God, I think I threw up a little bit. I think I just. I'm sorry. Hang on. Yeah, no, I'm absolutely not. I would move to a simple thing where that unmanaged code can be instantiated, controlled, isolated, redundant, so that you have them behind a load balancer.
And potentially even relocated to
put them on another
host.
host. And depends on what that call does, but your .NET code or your ASP.NET code might be much more efficient and stable if it's able to just make a remote call or remoting call in order to get that done. Might be very easy to do that. So that's interoperability or interop, and you can measure that within.
And by the way, you want to look at the different types of interprocess communication mechanisms that you have available to you. Mark is suggesting using like an HTTP web service call. I jokingly use DCOM. There's also named pipes, which are internal to the operating system. And some of these are faster than others. So if you're going to be calling a remote service that you're going to be calling quite often, having the lowest latency service or lowest latency interface will be to your advantage in this case.
Yeah, I've even seen people actually do stuff on a crossover cable just to cut down the noise and do really fast interop calls to or calls out to a web service in this way. So that may be one thing where you'll find it most commonly where you have really old applications getting converted into .NET and they need to coexist. So there's an old calculation library or actuarial calculation library or something else that's running from C++, and it's, the nice thing is C++, you could recompile that code into being managed, C++ is kind of iffy that way. But like old C code, C libraries, or other things, chances are you're going to have to leave them. Which brings me to another idea: is that if you one of the main things an ASP.NET app does is call a database. So if you're using the SQL.NET SQL client, the native client, the SQL Server client, or ODBC, I like ODBC because it's kind of generic. But if you're in a .NET CLR making JDBC calls,
nah, that just doesn't work.
There's some goofy.
That's crossing the wires. You're gonna get the Stay Puft Marshmallow
You're much
Man.
better not trying to make a JDBC loaded into .NET. Although people have tried it, and I've seen some articles. If you start mixing .NET and Java within the same system, you're better off staying at higher levels in the stack to move data back and forth, not something low.
Or you should go and find a dusty copy of Microsoft J++ that actually runs in the CLR.
Or F#. F# would go there.
Or C#.
Yeah. Okay. So, boy, then in a nutshell, James, what are your closing thoughts here about .NET performance?
So the biggest ugly item that's a tell on .NET performance is this whole concept of state management and pushing it down to the client. So I would say that if you run into a state management variable that's anything more than a half a meg, 1, you should go to the developer. 2, you should take a cane. 3, you should beat them. And 4, you should deny them chewing gum for the next 6 months.
Sounds good. My tip is a shout out to my old buddy, Clint Huffman, who still works at Microsoft in the performance. He's a premier field engineering guy, PFE guy. He wrote a book called Windows Performance Analysis Field Guide, which is pretty cool. Like if you were into bird watching or something, it's a field guide. But he wrote it with the support of a bunch of his colleagues. So you can look for it. It's Clint Huffman, Huffman, Clint. And it's Windows Performance Analysis Field Guide. It's loaded with all sorts of fantastic tips. He's a brilliant engineer, and I started with him a long time ago.
Was he a premier field engineer?
Dude, I already said that.
Oh, okay, yeah.
Why, yes, he was, James.
It's one of those days, Mark.
Well, PerfBytes listeners, once again, you've come to the close of another JIT-compiled and interrupt episode of PerfBytes. And as always, we'd like to thank you for taking time to listen to the show today.
Mom, thank you for listening.
Yes. And of course, I'll always say thanks to the sexy Irish voice of PerfBytes. And special thanks to our great sponsors, SmartBear and Sosta, for their sponsorship and support of the PerfBytes show and you, the PerfBytes community.
Mark, today's show is powered by the thorium cycle, not the uranium cycle. Just as much fun without all the bang.
All of the content of the PerfBytes episodes are actually 100% copyrighted and protected by the exceptionally rare earth. These magnets will selectively seek out copyright violators from as much as 2 continents away and cause their monitors to distort. You can steal it, but you won't be able to see it.
For more information about PerfBytes, visit the show's website, www.perfbytes.com, or follow us on the Twitter, the Tumblr, and the Facebook. And of course, you can always subscribe and listen to the PerfBytes podcast on iTunes, iHeartRadio, TuneIn Radio, Stitcher, and testingpodcast.com. Just open your favorite listening app, search for PerfBytes, and click the subscribe button. And you might not know this, but you can also send us an email to ask@perfbytes.com, or even leave us a voicemail at 77-LOAD-PERF. That's 775-623-7373.
Please keep in mind that the PerfBytes show and staff are supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, Test Bash, the Ministry of Testing, the Computer Measurement Group, the Workshop on Performance and Reliability, and, of course, the Software Test Professionals community of software testers. Of course, we hope to see you at the next STPCon, which I believe is going to be in Boston in the fall. Join us there for a live PerfBytes episode, great performance testing workshops, training, and, of course, some single malt scotch tastings. James, who knows what we'll bring to the next STPCon.
And of course, Mark, it's that time. Ride 'em, Jackalope!
Yeah!